Hey, so today my group is going to be talking about ApacheJena. Okay, so just a bit of background. Jena was actually originally developed by researchers in HP Labs starting in Bristol, UK in 2000. It's always been an open source project, which is awesome, and it's been extensively used in a wide variety of semantic web applications and demonstrators. In 2009, HP actually decided to refocus development activity away from direct support of development of Jena through remaining supportive of the project's aims. And the project team actually successfully applied to have Jena adopted by the Apache Software Foundation in November 2010. So currently, Jena entered incubation with the Apache in November 2010 and graduated as like a top level project in April 2012. And this is actually their current status listed on their website. Kind of getting away from the history and just more into what Jena actually is it's a Java framework for, again, building semantic web applications. It provides an extensive Java library for helping developers make code that can handle RDF, RDFS, RDFA, AL, SparkQL, in line with published W3C recommendations. It also includes a rule-based inference engine to perform reasoning based on AL and RDF's ontologies, and a variety of storage strategies to store RDF triples in memory or on disk. So the installation process is extremely easy. I showed a couple ways to kind of go about installing. The first way is we're going to install the ApacheJena Fuseki. It's, as you can see, there is a download button to the left. So you click that. So kind of a little bit of background into this server is it's actually a SparkQL server. It can run as an operating system service, as a Java web application, and as a standalone server. Fuseki is tightly integrated with TDB to provide a robust transactional persistent storage layer and incorporates Jena text queries. And I have also during this tutorial will show kind of how to work with it in Eclipse as well. But again, to start, I'm focusing in on Fuseki. So again, as I mentioned, on the left, what you're going to want to do to start is you're just going to want to click the download link, and which I've shown on the left. And then on the right, what's going to pop up is this photo, this web page. And what you're going to actually want to download is the zipped file, which I circled in red. And it's pretty quick. It doesn't take a super long time. And you're actually, let me go back really quick. You're going to want to copy that file once it's been, once you started downloading it, you're going to want to copy it to your C drive and of course extract it. Once it's been extracted, you're going to want to create a folder named data, which of course is where the data will go within this folder. You'll then open up on the right. I've included kind of an image of what all this is going to look like while you're doing it. You're going to want to open up your terminal, and you're going to want to check just to start the Java version that you have, just to make sure it's up to date, because you can't have it be later than 1.8. And you're also going to want to then locate where you have put your ApacheJena Fuseki. And again, in my case, I have put in the C drive. So I've used the CD command to get to it. And after that, the following command, which is the Fuseki server command, it's going to update it and kind of like start the server and service kind of. And again, as you can see on the right, that's kind of what it's going to look like once you've started it and started running. The next part would be to open up a web browser. It recommended on the website on ApacheJena's website, it specifically said Firefox for some reason, but Google Chrome is also one you can use. But in the search bar, you're going to want to I put it on this slide, the localhost 3030. Just copy and paste that into your search bar, and it's going to pop up on the photo on the top. If you can see, there is a green circle to the right, and it is the server status, which in it's green, which means it is ready and it is running, which is perfect because that means you can start working with it. Also within that photo, you can see an add data button within there. It's in the middle, kind of the blue button. This is kind of where you can then import data sets. and just kind of start working with them. So kind of moving on to the Eclipse side of it, if you wanted to work with it in Eclipse, these are kind of the steps you would need to take following 5 and going forward. So obviously to start, you need Eclipse downloaded and you need Java JDK version 1.8 or higher, which I have not included that in this tutorial because that is not what this tutorial is about, but everyone's OS operating system is different, so I can't include that. But so these commands are going to be what you're going to want to input into your terminal again. The git command is going to access the Jena source code in the Apache Git repository, and the CD is again to locate get to the Jena. And the mvn clean install command that I've listed is important because it will allow Eclipse to be able to find all the local artifacts with no issue. After you have started those or finished off those commands, you're gonna go to Eclipse, and Eclipse actually comes by default with Maven integration. So in the past, you would have to install and configure a plugin for that, but obviously not anymore. Once it's been downloaded, once you've finished uploading or getting into Eclipse, you can go and import source code. So in the picture that I have to the left, you can see an empty Eclipse workspace. The view is configured to display working sets, and there is a Jena working set already created. This isn't quite necessary for this tutorial, but you might find it useful if you work on separate projects at the same time. So in my example, if you click the Jena project, it will open a menu dialog, which I have listed on 7A in that photo, where you will find several types of projects to import into your workspace. So for Jena, we want to select import existing Maven projects, which is located under the Maven project category. And then you're going to click next, which will then bring you to the image of 7B that is present on the screen. This is where you're going to choose the location of Jena source code, point it to the folder where you checked out the Jena source code in the previous section of this tutorial. And once you've done that, you're going to obviously submit, click finish, and then Eclipse is going to start importing your project. And just kind of depending on your system and how old your computer is, whatnot, this can kind of take a couple minutes to load all the resources. So once everything's been imported, the image on the left is kind of what you're going to be seeing. And again, it's going to be taking kind of a couple minutes to start building. After the import process is complete, it will start to build the project automatically, but that's if you have it configured with the default settings. If you don't, that's an easy fix. All you have to do is click on Project Build All. And there will actually be a build issue that will be coming up, which I have shown on the right. As you can see, there's a ton of like project issues, just a bunch of red X's on the image on the right. And it's a really easy fix. So Eclipse is actually displaying all these red icons in the project folders with build problems because the build problems are related to a known issue due to how the project shades Google Guava classes. The workaround is to make sure the Jena shaded Guava Maven module remains closed in Eclipse. And you can do this by simply right-clicking on the project, which I have highlighted in blue on the right. If you just right-click it and choose close, its icon should change, indicating it's been closed. And after that has been shut down, the next step that you're going to want to take is you're going to want to trigger a clean on all projects so that Eclipse can clean and rebuild everything, which you also are going to want to update the Maven project setting so that Eclipse is aware that the project is closed, and it will also use a local artifact rather than the module in the workspace, which is kind of the MVN code we had kind of referenced earlier. But as you can see on both the images, I've shown where you can locate the project clean button and the Maven update project. After you've done those, it should now successfully be built. And now we can test Fuseki now. So for example, if you want to expand the Jena Fuseki core Maven module, you can then go to the org.apache.jena.fuseki.cmd package and run Fuseki CMD as a Java application, which I have shown in the image on the right. once you have started the Java application, you will have started to initialize Fuseki, and it will be listening on the local host 3030. Which, having that done, you can now start to debug Jena, modify the source code, and build the project again, or import or create other projects into your workspace and use them with the latest version of Jena. And that concludes the introduction and installation portion of this project.
Hello, how's it going? My name is Lucas Rayner, and I'm going to be talking to y'all today about the basic usage of ApacheJena and just more in depth about the RDF representation and what that exactly means and how we can use the Jena API to basically look into some semantic web applications and how we create ApacheJena models. So by now you've probably heard a good brief introduction into ApacheJena and you've seen how we install it. So now let's dive into what we can use it for and what exactly a RDF graph is. So if we look at RDF representation, this is an RDF representation of a V card. And a V card is essentially a property or a basic tuple of a ApacheJena API. So how we actually represent a V card is through Java, and the Java API for a vcard looks like this: public class vcard extends java.lang.object. So you can actually find the vcard class in the Java API. So ApacheJena is not, this is a common misconception, and you'll learn more about this later, but it's not a standalone entity. It is built on top of another interface, and you can interact with that to use the RDF tools and the toolkit that ApacheJena provides us to optimize web applications. So let's keep diving into the RDF representation. So John Smith, as you can see on the right, is the resource. So similar to what we've been learning in SQL and the entity models, John Smith is a resource, and in the ApacheJena RDF, it is shown as an ellipse, and it is identified by a uniform resource identifier called shortened for URI. So essentially, and this goes back to how ApacheJena interacts with web applications, this is going to be represented as a URI that has an absolute path that can be accessed, and then it's going to have properties that go on top of it. And these resources, the ellipse, have properties that can be manipulated by the ApacheJena API and be added to and given attributes, just like in SQL, how we give attributes to different entity types. So now let's keep expanding our knowledge about RDFs and how ApacheJena uses them. So let's look at some code about how we actually create this model in ApacheJena. So a model to ApacheJena is basically like a ER diagram to SQL. So it basically represents all of this information, and it kind of gives you a visual about how ApacheJena stores and utilizes the information. So first thing we need to find is we need to find our URI, and we're just going to keep on with the theme of John Smith. So http / John Smith. So this is, again, we're going through the lens of a web application. So this would be on the front end of a web application where we would have this John Smith that would then open us up to the rest of these properties. So now we just clarify in a static string, just some attributes of the resource. So the name is John Smith. And this is actually where we create essentially the ApacheJena table. We create an empty model. And like I said, the model is essentially like how ApacheJena represents its data. And so we model through the RDF API or through the ApacheJena API. The code right here is to create a default model. So this is creating this structure right here. So then we create the resource, and again, it's just a simple line of code that says resource John Smith, model.create resource person URI. And we add the property John Smith dot add property, and we give it the vcard.fn and so we label that this is this connection. So again, the vcard is almost like a relationship type. So this vcard is going to represent a connection between the resource and the property. So the resource is John Smith. It has the URI, HTTP, absolute path John Smith. The vcard, which we're naming FN, which is abbreviated for full name, is what connects this to the property. The property is the full name, which we created in a string called John Smith. So as you can see, this is how all these parts come together to make this diagram right here. So let's look at how this becomes more complex as we expand our property and resource definitions. So as you can see, as we add more properties, our RDF gets bigger. And I just want to point out that RDF actually stands for Resource Description Framework, and it just is it's a fancy word for how a web application describes resources, essentially. So as we add more properties and vcards, our RDF gets bigger and more informative. As you can see, we still have this full name, and then we made another relationship vcard called in that that is supposed to be for the compound name of John Smith. So as you can see, we initiated a new resource as the value that the property takes into it, but it doesn't have anything in it right now. It's not it's supposed to represent the compound name, but it has no URI. So we don't directly access the compound name. We directly access it through our the first URI we created. We have this relationship that leads to this property of a compound name that is given an ellipse. And this ellipse, this is important, it doesn't have a URI, but still represents something unique to the John Smith resource RDF as a whole, is called a blank node. So this would be called a blank node because it doesn't have a URI, but it still represents a property of John Smith, the compound name. So as you can see, then we have two vcards coming out of it for the given name, what he was given, John, and then his family name.
So let's talk about the use cases. The use cases of ApacheJena. So I will use as an example OpenPremID from Refinitiv, which is freely available at this link provided in the slides, by the way. So PremID is a shortening for permanent identifier, which is a machine readable number assigned to entities, securities, organizations, companies, government agencies, universities, etc., codes, individuals, and more. It is specifically designed for use by machines to reference related information programmatically. OpenPremID also provides bulk files, one per entity type, containing the complete lists of the entities, including organization, instrument, code, asset class, currency, instrument code, and person entities. These files are updated weekly. The following picture represents the relationship among the entities. So as you can see, this screenshot represents the entity types in the OpenPrem ID. In order for you to give a broader and a better picture of what we are working for in the ApacheJena, this is just an example. You could use anything, but for this example, we are using OpenPrem ID. So here you could see the main entities: person, officer role, organization, instrument, codes, and everything else. Moving on, the following steps demonstrate how to load organization, industry, and code files into the ApacheJena TDB. First, download organization, industry, and code files from premid.org website. There are two types of the file, TTL and NTriples. In this step, NTripple files will be used. As you could see, to avoid any confusion, I have included a screenshot which focuses and highlights the NTripple files for users. Next, after downloading, our step is to decompose those files and rename the files extension from ntriples to nt. Next, run the following command in the ApacheJena directory to load those files to ApacheJena TDB. The location of the database is at C workspace database, just for this example. It could be anything depending on which machine you're using. And so here, if I had to explain the command that we are using, all it does is it's specifying a location and decompressing the file we just downloaded and changing their extension from ntriples to nt. Now, once you have populated the database, after using that command and after loading our entity types, this is how it's gonna look like. So this screenshot tells you how exactly your result is going to show up on your screen. At this point, the database is ready, and SPARQL can be used to query the database. SPARQL is a query language that we use for ApacheJena. For example, the following SPARQL lists active US companies in the healthcare providers and service industry. So next, this is how the SPARQL language looks like. And this is a small example of how we are going to use it in order to load PremID. The results containing organizations, prem IDs, organization names, exchange codes, tickers, market identifier codes, MICs, and routers, instrument codes, RICs. The query can be run through tdb2 tdbquery.bat command. So after running the command, the result is just going to be similar to what is shown in the screen below. Moving on, we are going to talk about the industrial adaptation of ApacheJena. Specifically for this example, I'm going to talk to you guys about one project in which they are using ApacheJena for storing, creating, importing a query set for the aviation data. The idea is to use a triple store to infer knowledge about aviation data using information from aircrafts, airports, carriers, flights, weather stations, ASOS, METAR weather data. The triple stores to infer knowledge about data in aviation data here for this project is ApacheJena. Now, what this project is about: in the internet, you often get idea of how to really read, transport, import, and query a data set. Most scientific papers you find in the area of semantic web don't share the data, don't share the query, and they often do not explain how to recreate the result. This today we are focusing. Specifically, the project will focus on building a RDF dataset using the .NET libraries, which they're doing on their own. We don't really have to focus on it. But what is important to us is creating ApacheJena TDB2 database and how they use it using database to connect it to their project, and efficiently importing the RDF dataset to ApacheJena TDB2 using the query language, that is SPARQL language, to query the data set. Now, just to see more about this project and learning more about how and what they're exactly doing with ApacheJena, and what needs to be done is, first, we need to define a SPARQL data service. And then second, we have to define the TDB2 dataset definition. In ApacheJena, this is done by writing a so-called Fusiki configuration file. This is written in the RDF turtle syntax. For example, this is how it will look like: the Fusiki server configuration file and the Fusiki server, the aviation service using the Fusiki services, and finally the RDF data type. And yeah, that's it.
So now we're going to move on to comparing the Jena software with other NoSQL technologies like Neo4j and Graph Database. And then we're going to move on to look at the limitations of ApacheJena. So comparing it with Neo4j, ApacheJena mainly uses an RDF store as its primary database model as compared to Neo4j, which uses graph database model. An RDF store is also called as a triple store sometimes because it normally stores data in triples, and it is retrieved via a query language. And unlike a relational database, a triple store is modified for the storage and retrieval of triples, like I said, in addition to queries. And it's really called RDF because RDF stands for Resource Description Framework. And the files which are stored using the RDF store can be, usually imported and exported using this primary database model. And moving on, Jena really just uses one language, to be honest, and it only uses that language for both implementation and when users use it, which is Java. Whereas Neo4j, it uses many languages which are used in the present world. I mean, it supports them, and when it comes to implementation, it can also be implemented in Scala in addition to Java. And now when we move on to the partitioning methods, it is not possible to find any partitioning methods in ApacheJena because it does not support partitioning, and Neo4j does, and it does it through the Neo4j fabric method. And when it comes to replication, again, no data stored using ApacheJena can be replicated, whereas if data is stored using Neo4j, it can be replicated using casual clustering. And that casual clustering is done using a REF protocol. And after that, Neo4j.inc is mainly the publisher for Neo4j, and ApacheJena is developed by the Apache Software Foundation. And now we can move on to the comparison between Jena and Graph Database. Okay. So again, just like the previous slide, Jena uses an RDF store, and Graph Database uses the Graph DBMS, Graph Database Management System. Apart from Java, Graph Database, as compared to ApacheJena, supports many other languages like JavaScript, Python, C#, and PHP, Scala, which we learned in PLC, I think, Ruby, etc. And again, there's no SQL support with ApacheJena. And when it is compared to GraphDB, there is an SQL support, and the data is stored through an SQL software called SparkQL, and that is done using an Apache calcite. And triggering is normally possible in ApacheJena using an event handler when it is not possible using a graph database. And after that, replicating methods, again, it is not possible in ApacheJena, but when it comes to graph database, there is multi-source replication, meaning like you can use the same type of data in multiple formats and in multiple places. And going back, I didn't really talk about what Apache calcite does. Apache calcite, it allows for multiple data models with the support for query optimization with query execution. So that's what it basically does. So it's kind of like replication, but not really. And since Jena does not support replication, let me talk to you about what replication actually is. It is the detection of an out-of-sync worker whose signature does not correspond to a known state in the transaction log. So if you're replicating or like making multiple files of the same data, if it's not, basically what it means is that if it's not the same as the previous data, for example, let's say you copy the data, but then you try to change it, that's not going to be possible in Jena. So that's what it basically means. And again, the developer for graph database is Onto Text. I've never heard of them before, but yeah, that's the developer. Now, let's move on to the limitations that you have while using ApacheJena. I think I did mention these before when we were talking about like the comparisons, but here we go. The main limitation is that there is no support for SQL, even though it is the primary database model is an RDF store. RDF store like normally uses NoSQL, but on the whole, Jena does not support SQL. Jena just uses an RDF store to, as its primary database. That doesn't mean that it should support SQL. They're completely different. And again, it can only be implemented in one language, which is Java. That is a really, what do you call it? A really drastic drawback in using Jena, because right now people have been changing from Java to Python or Swift or JavaScript compared to Java. So right now, like the computer science market is drastically adapting and changing to the real world needs, because artificial intelligence is basically coming up so much, which is why the usage of Java is decreasing rapidly. Mainly, I would say it's only used for making games at this point, really good games. And apart from that, I can't really recall what it's used for. And again, it does not redundantly store data on multiple nodes. So that means that it keeps the data even when it is not needed anymore. I mean, you access the data, you return it to the user, and then you might not need it in the future because you're never going to need it. For example, if let's say a customer orders an item from a website, and then it's delivered and the customer is satisfied, and that data, the shipping data or like the product tracking data, might be stored, and it's not useful anymore when the product is delivered. Like no one is going to look at the tracking data once the product is delivered. So Jena does that. It keeps the data there, which takes up a lot of space, and it also takes up a lot of RAM too. And apart from that, Jena does not really have any methods, or it is not capable of storing different data in different nodes. So these are like the basic disadvantages of using ApacheJena. And apart from that, I would say that, the fact that Jena only uses Java is, for me personally, the main concern, because I don't really, I'm not really proficient in SQL as of this point, but compared to Java, yes. So personally for me, that might be the most drastic disadvantage. And moving on. Oh yeah, there we go. This is our work setup page. And yeah, that's it. That's ApacheJena. That's how you implement it. And that's what ApacheJena is used for, as described before by me and my teammates. And I would just like to say that, I don't think Jena is the best SQL technology out there, because there's so many SQL technologies which are so much better than ApacheJena. But I would say that, when the time that it was released, I would say that many people might have used it, because I don't think NoSQL or Graph database have been introduced by the point, or by the time Jena was introduced into the market. Apart from that, that's all there is to talk about this. And thank you very much. We really appreciate it.